So let's look at a couple more examples of using these geometric sequence formulas. And notice that this formula gives us the first term and it gives us the pattern. So recall that this is our recursive formula. And with the recursive formula, we can figure out the first term and the common ratio. Since let's just write this out generally. So d of 1, remember that's just your first term in the sequence. And to find that nth term, it's always going to be the term before it multiplied by r, where r is our common ratio. It's the number we multiply by to go from one term to the next. So comparing this to our general formula, we know the first term is 8, and we know our common ratio, since that's whatever is multiplied by this d of n minus 1 term here. So looking at this specific example problem, we know the first term is 8, and we can figure out the common ratio from this pattern here. We know that to find the nth term, or the next term, that we're going to look at the term before it and multiply it by the common ratio. And since we're multiplying by -5, we can figure out that r, our common ratio, is -5. So to go from one term to the next, we'll just multiply by -5. So we could generate the sequence that way, but let's actually plug in the values to our formula and see what we get when we get up to our third term. So we know d of 1, but let's find d of 2. So now we're just setting n equals 2 here. And plugging that into our formula, we have d of 2 minus 1 multiplied by -5. And d of 2 minus 1, that's just d of 1. That's our first term. And we'll take our first term and multiply by -5. So 8 times -5, that's -40. So let's start writing down what our sequence is. We know we have 8 for the first term, then -40 for the second, but we need to find the third term. So let's plug in d of 3, since now we know d of 2. And when n is 3, we have d of 3 minus 1, which is just d of 2. So the second term multiplied by -5. And the second term was -40. And -40 times -5 would be positive 200. So that is our third term. That's what we're looking for. So this should be our final answer. But if we wanted, we could keep going with this, since now we see the pattern. Since to go from one term to the next, we're just multiplying by that -5. So to find that fourth term, we multiply 200 by -5, we get -1,000. To find the fifth term, we multiply again, the negatives cancel, and we get 5,000. And this will go on forever. And once you get good at these problems, you really just need to identify that common ratio and then start multiplying your first term by that repeatedly. So you don't have to do all this work, but doing all this work will double check that the third term is in fact 200. So let's do one more problem. And for this next one, we're going to look at the explicit formula. And the explicit formula, remember, is very useful when we want to find a particular term in the sequence. So before we actually look at the example, let's just remind ourselves what the general form of this is. So if we have d of n, it's always equal to the first term multiplied by the common ratio raised to the n minus 1 power. Where again, r here, this is just our common ratio. So we could take our specific example and compare it to the formula. For instance, just matching these up, we can see that d of 1 would be this value 3. And you could check this by actually plugging 1 into the formula, since we'd have 3 times -2 to the 1 minus 1, or 3 times -2 to the 0, but anything to the 0 power is just 1. So you would get 3 here, proving that the number on the outside, when the common ratio is raised to the n minus 1, is your first term. Now, to find our second term, we could continue just plugging in n equals 2, but we can also match up with the formula and notice that our common ratio, in this case r, is the number in parentheses here raised to the n minus 1. So r would be -2. So going one term to the next, we're just multiplying by -2. But like I said, we could also just plug 2 into the formula. You get 3 to the times -2 to the 2 minus 1, or just to the first power. And 3 times -2 is -6. So let's start writing down our sequence here. 3 is the first one, -6 is the second one. And you don't have to do all this work, but I want to give you a way to be able to check, to make sure that you are getting the correct answer. In reality, once you get a lot of practice with these, you can just plug in 4 for your n value and see what you get from the formula, since that's basically the whole point of these explicit formulas. It's so that you don't have to generate the sequence yourself. But regenerating the sequence just gives you a way to check your work. So let's do a couple more. We want to find d of 3. That will be 3 times -2 to the 3 minus 1, or just 2. And we're squaring a negative. -2 times -2, the negatives cancel and we get 4. And 3 times 4 is 12. So our third term in the sequence is positive 12. And we'll do one more. We could find d of 4. Plug in 4 to our formula with 3 times -2 to the 4 minus 1, or just to the third power. And if you multiply -2 3 times, you will get -8. And 3 times -8 is -24. So this is our actual answer. We could have just done that from the start. But like I mentioned, we also want a way to be able to check these and to notice the patterns. Since going from one term to the next, notice our common ratio, we are multiplying by -2. So that does match up with our formula and with the evidence that we have. But for instance, if let's say we wanted to find the 16th term, we don't have to do all this work. We could check it by doing all this work, but in reality, we can just plug 16 into the formula, and we get 3 times -2 to the 16 minus 1, or the 15th power, and that's going to be a pretty big number. It will be negative, but you can put that into your calculator to find it.